guys, this is the video on determining empirical formula of compounds. So for example here NO2 is the empirical formula. How did we get this NO2 from the molecular formula N2O4? So for N2O4, this 2 and 4, you can actually reduce them to the smaller ratio by dividing each number by each subscript by 2. And you get NO2. You can't further simplify these subscripts. They don't have any other common factors. So this one is the empirical formula with the smallest ratio of atoms. So what is an empirical formula? This is the formula of a compound with the simplest whole number ratio of atoms. So we want to make sure that it is the whole number. And we are going to use all the step-by-step process to find the empirical formula. Here H2O, however, you see the difference between N2O4 and H2O. For H2O, the empirical formula and the molecular formula are same. So in case of covalent compounds, so this is a covalent compound, this is a covalent compound, molecular formula and empirical formula may or may not be same. Like in this case, it's not, and in this case, it is. However, in ionic compounds, molecular formula and empirical formula are always equal because the ratio of atoms is already in the simplest form. Let's start with the example. Chemical analysis of a certain compound shows that it contains 52.94% of aluminum and 47.06% of oxygen. We have to figure out the empirical formula. So we need a periodic table, so please have your periodic table ready. Whenever you have these problems given in percentages, you just assume that sample is 100 gram for the sake of simplicity with the calculation. So let's start out with what's given. This is given and this one is given. So aluminum 52.94, I'm going to write down grams of aluminum, and then 47.06 grams of oxygen. Okay guys, and the next step, so this is the first step, assume 100 gram sample. Second step is convert mass to moles. So we need periodic table here to figure out the molar mass of each element. So let's figure out for aluminum how much is the number of moles. So 52.94 grams of aluminum. This is given. You always start out with given. We are using dimensional analysis method for the conversion. And what do we have to find? We are converting mass to moles, means grams to moles. So when we write the fraction, we want to have our moles at the top. So 1 mole of aluminum has how many grams? In order to tell how many grams, you look at the periodic tables. And we look at the periodic table, 26.98 grams is the mass of 1 mole of aluminum. Guys, always round off at the 100th place when you are reporting the molar mass. Now you're going to cancel this out. As usual, for dimensional analysis method, use the calculator, divide this number by that, and you're going to get 1.962 moles. Guys, always pay attention to the significant figures as well. Like, keep them in mind. Oxygen is start out with 47.06 grams of oxygen, and in 1 mole of oxygen, again refer to the periodic table, the molar mass, and you round off that molar mass at 100th place, and you're going to get 16.00 grams of oxygen. Cross out the same units and you're left with moles again, and divide these numbers, 2.941 moles. This is what you are going to get. Okay, just make sure you're using periodic table to get all these molar masses. Right, now our job, the next step says divide each number of moles by the smallest number of moles to get the simplest ratio. So this is not the simplest ratio yet. So aluminum, how many moles we got? 1.962. Okay, and for oxygen we got 2.941. To convert it into the simplest ratio, we are going to divide by the smallest number of moles. So which one is smaller here, this or that? Is 1.962, and this also divide by the smaller number, 1.962, smaller number of moles. Use your calculator. When you divide the same number, you always get 1. The subscript will be 1. And when you divide these two numbers, you are going to get 1.5. Okay, we can't leave this as a fraction. So step number 4, you have step number 1, 2, 3, 4. So step number 4 is not always used. It's not needed, then we don't need it. However, whenever you don't have the subscript whole number, then we need to use this step number 4. So how do we make this fraction a whole number? We have to look for the small whole number. You always look for first the smallest whole number. And if that doesn't work, then you go to 2 doesn't work, to 3, 3 doesn't work, to 4, like that. So 1.5, if you multiply this whole thing by 2, it will become 1.5 times 2 is 3, and then 2 times 1, 1 times 2 is 2. This will be, okay, this is the final formula of aluminum. This is aluminum oxide. So for 2 aluminum, we need 3 moles of oxygen. Okay guys, so that is how we figure out the empirical formula. Once again, the step number 4 may or may not be needed, depends on the problem. Okay, now let's start with another problem. Actually, let me do this one more. This is for ibuprofen, and as you know, ibuprofen is a compound which is actually used in painkillers, and it's made up of carbon, hydrogen, and oxygen. We have to find out what is the empirical formula for ibuprofen. We're going to use the same rule. You're assuming that it's a 100 gram sample. So for carbon, so this is 75.69 grams. I'm going to write it here, grams. All right, grams, grams, and grams instead of percentage. And for carbon, we do the same thing, use the dimensional analysis method. We are going to convert mass to moles. When you do mass to moles, you are going to start out with given, which is 75.69 grams of carbon. Use the fraction where you're going to have moles at the top, because that's your desirable unit. So 1 mole of carbon, use the periodic table, get the molar mass, rounded off at the 100th place. Cancel the same units. When you use the calculator, divide these, because this is 1 here. It's not going to make any difference whether you do times 1 or you don't do it, but you need to divide these numbers, and you're going to get 6.302 moles of carbon. Now let's do moles of hydrogen. Start out with given, which is 8.80 grams of hydrogen times 1 mole of hydrogen. Use the periodic table, and for hydrogen, when you round off at 100th place, you get 1.01 grams. Do the same thing, cross out 8.71 moles of hydrogen. That's what you're going to get when you plug in these values, numerator divided by denominator, in your calculator. Oxygen, 15.51 grams of oxygen. This is our given. Okay, we always start out with given. Now times, since I have to find moles, I keep my mole at the top, divided by the mass from the periodic table, which is for oxygen is 15.99. You round off, you get at 100th place, you get 16.00 grams. Right? Grams of oxygen, cross out, and you're going to get 0.9693 moles of oxygen. So these are all the moles. Now the next step says we have to divide each number of moles by the smallest number of moles. So which one is my smallest here, guys? And if you look here, the smallest is 0. This one. This is my smallest. So I'm going to divide each of these moles by the smallest number of moles to get my simplest whole number ratio. So I have carbon, I have hydrogen, I have oxygen. So I have 6.302 from here. I have 8.71. Okay, and I have 0.9693 for oxygen. Divide each one by the smallest. Each one by the smallest. So same number when they are divided, numerator and denominator is same, that is 1. So this is 1. You divide these two, you divide these two. Numerator always at the top, divided by the denominator. You're going to get 6.5. Hydrogen, when you divide these numbers, numerator by denominator, you're going to get 8.98, and you can round off to 9. And oxygen is 1. So this is whole number, this is the whole number. However, this is not the whole number. So our job is, if the subscripts are not whole numbers, then multiply all subscript by a small whole numbers. So if I do times, then 2 times 1 is 2, 2 times 9 is 18, and 2 times 6.5 will be 13. So 6 carbon, 13 hydrogen, 18, and oxygen 2. This is the empirical formula of ibuprofen, this one. Okay guys? Alright. So how can you tell this is the empirical formula? Because there are no more factors for all these 3 subscripts. You can't, reduce them further. That's how you know. I want you to try this problem on your own. Let's see. Here, I have all the steps, but I want you guys to try on your own. Analysis of calcium bromide reveals that it contains 20.0% calcium and 80% of bromine. You have to calculate the formula. So go ahead, pause the video and do on your own. There you go. So if this is what you are getting, that means you're actually understanding it. But don't stop here. You need to practice more. And guys, just make sure you know these 4 steps. Once again, step number 4, we may need or we may not need. For example, in this case, we didn't need step number 4. We don't need step number 4 since we didn't have the decimals here to multiply further. It was already a whole number. All right, and this is called the train track method. You can use the train track method. This is another way of showing dimensional analysis. And please don't forget about the number of significant figures whenever you are converting mass to moles. See, I always kept my significant numbers. So for 1, 2, 3, well, this was 3 in the numerator and denominator, so no problem. But in this case, 1, 2, 3. So I had 3 because they were same. However, 1, 2, 3. 1, 2, 3, 4. You have 4 significant figures. But in my answer, I kept only 3 significant figures because we go by the smallest number of significant figures. Okay, guys. So here, just try this. I'm giving you the answer. The answer is right here. You're calculating the empirical formula for caffeine, which is found in coffee beans and a little bit also in tea. So here is the answer, but you need to show all the steps. Thank you for watching.